next up is single replacement. Single replacement reactions are where cations replace cations or anions replace anions. The way we think about this in day-to-day life is if I had two people who were dating and someone else came in and stole one of them away, and so we form a new couple. So general form is going to be either A plus BC yields AC plus B, or A plus BC yields BC plus A. And the only difference in those two is if it's an anion or a cation. So here A is going to be the cation, okay? And in my second, A changes to be the anion, and the way I know that is because it's second and it's first. So depending upon what's being replaced by what, is going to determine my new, order in my reactants. So there's another important piece in predicting products for single replacement reactions, and that's the activity series of metals. So in your purple and pink sheet, your reference tables, I need you to turn to page 7. This is the same page that your polyatomic ions are on. And you'll note that there's both an activity series of halogens and an activity series of metals. So the way that we use this is things that come above replace what's below. So for example, lithium will replace everything below it, Li, which is listed first, and then gold, which is at the very bottom of the list, will replace nothing. So lithium will replace rubidium, potassium, barium, strontium, calcium, sodium. So if it's above, it replaces anything that's below. All right. If it's below, it can't replace what's above. So for example, rubidium can't replace lithium. Potassium can't replace lithium. It has to be above it in the list in order to replace it. So let's practice some of these. Calcium plus water. First thing I need to do is go ahead and write my chemical reaction. Ca plus H2O. Now, what is Ca? Ca is a cation. It's a metal. So when I use my reference sheet, I'm going to look at the activity series of metal. And what I'm going to look for is, will calcium replace hydrogen from water? So is calcium above H2 in the activity series of metal? And you may be surprised to know that H2 is listed in the activity series of metals. It is listed right between plutonium, or lead, sorry, Pb, and antimony, Sb. So if you look, it's the third line down. Hydrogen is right below that. So calcium is above hydrogen, so it will replace it. So calcium is actually going to come in and kick this hydrogen out. Calcium's going to rebond with that oxygen, and then I'm going to be left with H2 gas. So Ca and O, calcium has a +2 charge, Ca has a -2 charge, so I'm going to form CaO. Because +2 and -2 cancel out to 1 and 1, we don't write 1s, plus the other element of H2. Now I can check to see if I'm balanced. 1 calcium, 1 calcium, 1 oxygen, 1 oxygen, 2 hydrogens, 2 hydrogens. At this point, I am balanced. So this is the process we're going to take for every single replacement reaction. So zinc plus hydrochloric acid, zinc's chemical symbol is Zn, plus hydrochloric acid. Hydro means it's a binary acid, so it's only H and another element. Chloric means that that other element is that other element is chlorine, so HCl. So what I need to determine from my activity series of metals is if zinc will replace hydrogen. And I know that I'm using the activity series of metals because zinc is a metal. So on my activity series of metal is zinc listed above H2. Well, zinc is in the second block. It's the, the fourth down in the second block. It's between manganese and chromium. And it is listed above hydrogen. So zinc will come in and kick this hydrogen out. So yet again, I will have hydrogen gas as one of my products. We're going to assume that the charge of zinc here is 2. So zinc plus 2, Cl, -1. When those crisscross, I get Zn, Cl2, and the other product is going to be hydrogen gas, H2. Now remember that H has no subscript here because of the charge of chlorine, but here it's because it's diatomic. Now I need to balance. I have 1 zinc on my reactant side, 1 zinc on my product side. 1 H on my reactant side, 2 H's on my product side. So I'm going to go ahead and balance that H. I have 2 chlorines on my reactant side. This distributes. And 2 chlorines on my product side. At that point, with just 1 coefficient, I am balanced. Alright, last problem. Bromine plus potassium iodide. Now, if we remember, bromine is special because it's a polyatomic ion. It's easy to remember that if you have the 7 polyatomic ions clearly marked on your periodic table. I'm going to add this to potassium iodide. Potassium, which has a 1 charge, iodine that has a negative 1 charge, is going to form Ki. Now, bromine is an anion. It's a negatively charged ion. So what we're looking at in this problem is, will bromine replace the anion of iodine from potassium iodide? So if I look at my activity series of halogens, because those are my negatively charged, is bromine above iodine? And it is. It is 1 step above iodine. So bromine is going to come in and kick out this iodine. It's going to go ahead and bond with that potassium. Bromine's charge is 1, so I form KBr, potassium with a +1 charge, bromine with a -1 charge, plus I2. Why does I have a 2 subscript? Well, that's because it's diatomic. Same reason that bromine has a 2 here. They're both diatomic molecules. So now I can balance. I have 2 Brs on my reactant side. I'm going to put a 2 in front of KBr to balance my Brs. I have 1 potassium on my reactant side, 2 potassiums on my product side. So I'm going to go ahead and balance that potassium. And in turn, it's actually going to balance my iodines for me. So with a 2 in front of Ki and a 2 in front of KBr, I am now balanced. And that is single replacement reaction.